What part do you think can Germany play in achieving this digital sovereignty and the energy sovereignty and solving this, let's say, energy crisis that we have right now?
It's not a physics problem anymore. It was turned into an engineering problem.
Good afternoon, everyone. I'm very happy to be able to moderate this panel discussion with you tonight. Very happy that you're here and that you're going to listen to this. I hope you can take some inspiration from this. This is something that I'm very interested in, not just because it's my company is part of it, but because I have a serious interest in this. The data centers industry is a hot topic right now, but what we are lacking a lot of times from my perspective is the academic angle and having a bit of really experts talking about the energy shortage, how to deal with it. We really just talk that it's there and that something needs to change, but we don't really talk about, okay, what's the research on this? Because we know we have great universities, we know we have great researchers, but we always seem to lag behind. So that's why I'm very happy that we got a senior scientist at one of the most interesting companies right now in that area. Please have a warm welcome for Professor Wasser. He's a senior scientist at Focus Energy, so maybe have a warm welcome for him. And then the next speaker of the panel discussion is one of the co-founders of firstcolo. He's the CEO of the company. He has a lot of skills. He knows really about the technology. He's been there in the data center industry from the very start. So please have a warm welcome for Nicolaj Kamensek. So, not to waste your time, I would say let's really dive into it and have a look at what is the industry perspective on this crisis right now that we can really talk about. So, Nico, let's start with you, right? From your perspective, we talk a lot about energy, but can you really feel that the energy shortage, especially in the Frankfurt market where firstcolo is based, can you really feel that it's something that's hindering you from having more growth? Is that something that's on your mind?
Yeah, absolutely. I mean, what we're seeing right now, we are close to a shortage. So when you ask for new energy in Frankfurt, it's very hard to get something. Sometimes it takes 5, maybe 10 years before new energy is being provided by the local grid providers. And what we are seeing is that technology develops much faster than actually the infrastructure behind for the energy. So therefore, there is a shortage. The question is only when does it happen, when it's going to be a showstopper. And therefore, what we are seeing in the market and with the competition is that the radius around Frankfurt is getting larger and larger, and companies decide where to build new data centers, actually where energy is available, and location becomes less and less important as long as you have fiber connectivity, of course, and access to good people that can work for you.
Thank you. So we are at the Cloud Fest. We talk a lot about the AI, right? And we know there's an energy shortage. So what would you say until which point are actually cloud and AI companies really responsible for the energy usage? Do you think that they have a certain part of responsibility? I mean, some of them are your clients, so you're really in discussions with them, right? What's their take on it? What do you think is your perspective on the responsibility that they actually have in the end?
Yeah, I think responsibility is quite big because when you think about it, cloud is already critical infrastructure. AI has the potential to become critical infrastructure in the near future. So therefore, we have a higher responsibility to manage those data and those workloads very secure. And if you want to be secure, you have to have your data nearby you in order to be in control of them. And I think what we need to do also, because there is such a high energy demand, we need to invest in more efficient models and better hardware and maybe an integration with energy grid systems so that we can use everything more efficiently. For example, when you see that PV systems provide energy only, let's say, 16 hours a day or so, it's possible to link training data so that they only run when there's energy available from renewable sources. So those are things that can happen in the future from my point of view.
Let's just jump to a hypothetical extreme, right? I think a lot of people are wondering, okay, data centers are taking a lot of energy. A lot of that comes from AI applications. Energy is getting more and more expensive. and maybe it's also a security issue. Would you say if we go to the extreme and we say, okay, we are not solving this energy issue, but we know that we're having a massive growth in the AI sector, should you think hypothetically at some point we should say, okay, we actually need to limit the growth of AI companies and of AI models and say, therefore, okay, we need to cut the power that's available to them and stop the growth at some point?
Yeah, I don't think this is the right approach, and this has never been the right approach to basically stop technology from evolving and from using them. I think we need to progress in different ways. So, for example, as mentioned before, invest in better models, more efficient models, smarter grids or smarter grid connections. I think this is the way to go, that we use the energy that is available very efficiently in the future. Maybe for sure there could be some point in the future where this is not possible anymore, but I would rather not think about it, and hopefully Professor Wasser will be able to provide very good energy sources in 10 years or maybe a bit quicker.
Maybe one more take from your perspective. We always talk about who has the superior technology. We talk about who has the talent to develop new technology. But do you think in the end it could also be a discussion about who has the infrastructure? First of all, to provide the energy and then to also use it the most efficient way and have the resilient infrastructure? Do you think it could come down to that rather than just a war of talent and technology?
Yeah, absolutely. I mean, what we're seeing already is that the locations are selected by the availability of power. So therefore, this has become a major decision maker for us. We see the radius of Frankfurt is getting bigger, especially for training data where latency does not matter that much. There's a big option that we can basically go to other cities in Germany where energy is still available. But of course, for data sovereignty, we need to be able to host those workloads within Germany or maybe within the EU. So outside the US is the important aspect here. The one thing to mention is the Cloud Act, which basically takes away all the sovereignty from everybody that is hosting with US public clouds, for example. So it's very important, and we need to make sure that we do not lose the run here. I mean, Germany is very good when we are looking at engineering and sustainable infrastructure, resilient infrastructure. So those are things that we can combine with very smart models and basically make sure that we are the leader in this area at least.
Thank you. So let's take a look at the other perspective. We're talking a lot about, okay, we're lacking energy, we know we want to grow, there's this growth, but we don't know how to match that resource demand. Now look at the other side of the people actually doing research. We have a lot of uncertainty around the production of energy. We hear a lot that nuclear fusion could be the holy grail of the future, could be a new energy resource, could be the solution to everything that we have. And then we have other times where we say, okay, but it's not here, right? So if we have it, if we know it's good, where is it, right? So then the question is it actually going to be a solution for the industry to the issues that we have? And if so, are we talking about 5 years, 15 years, maybe 50 years? What's your take on that?
Yes, so there's actually a running gag that whenever there is a question, when would fusion energy be available? The answer is 30 years, and it doesn't matter when you ask that. So if you ask that 10 years ago or today or in 30 years, the answer would always be 30 years. I think I know where this running gag came from. The reason was that not until recently it was not clear if the fusion process that we want to establish here would work. So it was a fundamental physics question, and with that it's impossible to plan and to know when this would be available in the future. And this situation has changed recently. Some of you might have heard it. There was a great breakthrough. Scientists in America from the National Ignition Facility achieved ignition of a fusion pellet and a gain greater than 1. What does that mean? It means they got more energy out of this fusion process than the energy they needed to start this fusion process. So for sure, this is the minimum requirement to have fusion energy, but it changed the situation. It's not a physics problem anymore. It was turned into an engineering problem. And it's clear there are still several open questions and several issues, several problems to be solved, but it's just engineering, and that is something we can plan. And with that, I would say 15 years is a good number. We at Focus Energy aim at having a fusion pilot plant in 2037. So 11 years from now. And with that, if we succeed in doing that, commercial fusion energy in the 40s is achievable.
Okay, and you said now it's going to be more of a problem of really getting this into operation rather than it being about pure theory. Do you actually, I mean, you also follow probably a lot of discussions, and we talked about it earlier. You probably heard a lot about the discussions of AI that's going on. Do you actually use AI applications? Do you use applications of the digital industry to maybe even solve some of your issues? For example, do you use AI to maybe even help you solve the theory, solve nuclear fusion issues that you have? So do you think actually the industry that you supply with the energy that you might create could also help you solve these issues that they're actually facing?
Definitely yes. So data science, AI, machine learning, this is really helping. The reason is the reason why fusion is so hard to achieve is that there are many parameters. There are tenths or maybe even hundreds of parameters, and we need to get the right combination of all these parameters to get the fusion process running. And this sounds like a classical machine learning problem, right? Finding the right parameters, tuning the parameters, finding the optimum. That's machine learning. And actually, the breakthrough that I just mentioned was mainly driven by AI and machine learning. You could follow a nice curve, so they are tracking the neutrons coming from this fusion process. Without going into the details, it's just more neutrons is better. And if you look at the number of neutrons over the years, this was a curve just rising like this. And then there was a point where it really went up and started to grow like exponentially. And this was when the scientists started to apply machine learning and artificial intelligence.
Very interesting. Now we have a topic that's also very interesting to me. Many of us are not experts in that field of nuclear fusion. I'm always saying that maybe as a data center operator, we have more knowledge and touch points to actually energy than we would like to have in an ideal world where this is not the resource limitation. But your company, Focused Energy, that you talked about, it's based in Darmstadt. So Germany. We hear a lot of press and news about Germany taking off the last atomic reactors of the grid. We have none operating right now. But on the same time, we also hear that we are investing a lot into nuclear fusion. Is that, from your perspective, visionary, or is that a bit schizophrenic that we are saying, okay, this technology that once used to be very promising, we are really trying to get rid of that now? On the other side, we have 15 more years for nuclear fusion maybe coming into operation. Do you think it's still a good way that we're going, or do you think we're having some issues in how we're dealing with this?
I think it's a good way, and I think it's the way we have to go. And it's absolutely not schizophrenic if we understand that fusion is the opposite of fission. So what they are doing in nuclear power plants is fission. So they split big atoms into smaller ones, and in fusion they just do the opposite, or we do the opposite. We have two light atoms and we combine them to bigger ones. So it's the opposite, and from that there are several differences and many advantages of fusion energy. So first, there is no radioactive waste, or almost no radioactive waste in fusion. So the main product of the common fusion reaction is helium. This is absolutely safe. You can fill helium in a balloon, you can even inhale it, and you will get a funny voice.
Which is not advised.
That's the only thing that would happen, but you will definitely not die in most of the cases, I guess. And second, the reason why fusion is so hard to achieve is also the reason why it is safe. So I mentioned all these parameters that need to fit together, and whenever some event happens, could be human failure, could be an accident, could be a terroristic attack or whatever, this would lead to at least one of the parameters to be de-adjusted, and this would lead to the fusion reaction just to stop. So the only thing that happens is the fusion reaction stops. So there's absolutely no big catastrophe. And besides that, both techniques share some common advantages, like it's both CO2 free.
Very interesting. Thank you for that. Looking at the two of you, we talk also a lot about data sovereignty, also at the CloudFest, for example. If we look at that, that also means or includes having an independent, resilient infrastructure, right? And what role do you think does energy play in this, both of you? Do you think it could be actually a key question also in the geopolitical tension, and then really be an asset to have this this control over the energy production, over the energy, and then in the end use this to have a resilient infrastructure? Or do you think no, digital sovereignty starts somewhere else, and where we get the energy from in the end is maybe not important? That could be the other extreme.
Yeah, maybe I'll start first. Yeah, I mean, energy is the basis of everything, right? So it's the core of data centers or every successful industrial country in the world. This has been proven many, many times before. And so it's very important that we have access to cheap energy, to save energy, of course, in order to, especially in current days, grow, basically keep up with the growth of AI, of cloud, whatever, because it has become critical infrastructure. In case of AI, it will be critical infrastructure. Maybe we are just in the transformation of this process. And so it's very, very important that we make sure that energy is really available in Germany. And I'm very happy that we are one of the front runners right now. And hopefully we will be the first that will be able to get a big jump in this area.
Right. I think fusion has the potential to solve this issue. So if you think of all the other energy sources that we have right now, in most cases it depends on where you are on Earth, it depends on the political situation, it depends on the availability of resources. And for fusion, this would just not be the case. So if we succeed to build a fusion power plant, this could be exported to every nation, and just with some education, every country, everyone could do that, and energy would be available for everyone.
Maybe just one last question with a look at the time, maybe one last statement. We all opened a lot of difficult topics, something maybe even seems to be a bit scary, but firstcolo and focused energy, they're both standing for pioneering technology made in Germany, basically, right? So looking at all of this and looking at all the press that we have around Germany, what part do you think can Germany play in achieving this digital sovereignty and the energy sovereignty and solving this, let's say, energy crisis that we have right now? Do you think we are in a good position, or do you think, okay, maybe our role is not that important right now?
I mean, I said it before, I think Germany is very good at engineering. So if there is one country in the world that is able to solve those issues and make data centers, for example, more efficient, it should be Germany. At least in the past it has been the case. So I'm hopeful this will be the case in the future as well. But also there are some things that you can do as a data center operator, for example. So we have the Energy Efficiency Act, which mandates some criteria that we, of course, have to follow, and we will follow with our new upcoming project. But of course, you can, for example, use AI to improve energy efficiency with the cooling situation by basically adding AI by looking at the parameters and look where is the optimal parameters to run a data center the most efficient point. And those things can be done in various areas as well. So I think it's the right approach to optimize the systems even further in the future. And hopefully we do it in Germany first.
So I think Germany has the potential to be one of the world leaders in both areas. We are very strong right now, and I think we have to do that. We have to aim for that leadership. If you look at the current issues we have in our economy, if you look at the car industry that is struggling right now, and there are other players in the world that rise up, and Germany is probably not anymore the strongest supplier there. And we need to look for something else. And these two fields really have the potential to also replace the car industry and to become something new. Germany is strong in engineering for fusion, or for the way we want to achieve fusion. Laser technology is very important, and Germany is very strong in that field, in the laser and optical industry and technology. So we definitely have the potential to get there.
All right, so let's wrap that up. Thank you, Nicolaj. Thank you, Professor Wasser. Maybe a warm round of applause. Thank you, everyone in the audience, for paying attention. I hope that we answered some questions. I hope that we opened some new questions. Maybe you took some inspiration, and we're more than happy to maybe have some very interesting discussions with you later, maybe over a cold drink. Thank you so much. What